asked you to find dx dt and dy dt for whatever weird reason. I asked you to do that. So dx dt is 3t squared plus 8t. And dy dt I know, it does that sometimes. Any questions about that part? The second derivative of x with respect to t. 6t plus 8. Second derivative of y with respect to t is 12t squared minus 6t. So you would call parts A and B a parametric in the parametric questions chapter, right? We found x of t, we have x of t and y of t. We found the derivative of x and the derivative of y with respect to time and the second derivatives. Well, suppose, just for fun, we defined a vector to have that x of t as its x-coordinate and that y of t as its y-coordinate. I've got a little bit too much side talking happening. So suppose we define a vector with those two x and y coordinates. Find a vector to represent the particle's velocity. Well, wouldn't it just be the dx dt, comma, dy dt as my vector? And what was dx dt? Oh, plus 8t. And then what was the dy dt? So that is what is known as the velocity vector. I know, right? We just world earth-shatteringly difficult, right? And what do you think the acceleration vector would be? 6t plus 8, 12t squared. So what that gives you is the velocity and or acceleration of the x component and of the y component. Right? So today we're going to learn, thank you, formulas for vector-defined functions. Vector-defined functions are very, very similar to parametrically defined functions. It probably is, but I would go ahead and write it down. It probably is in some packet somewhere. The one that's the formula list. But just in case there's one missing, I'd go ahead and write it. So I'm going to give you a minute to write these down. The particle's position vector is the vector where the x component and the y component are parametrically defined x of t and y of t. The magnitude of the position vector is the length of the vector, which is, what is that formula on number 2? Pythagorean Theorem, right? So that is the magnitude of the position vector. The velocity vector is the derivative of the x component and the y component. Yes? No, it's a vector notation. It's just r of t is the vector. Do you use a hat in, what do you use in physics? It's just the vector r of t. I think it's a line with an arrow. What it is, yeah. Yeah, a line with an arrow. I think that's what that is up there. It does appear to have lost its arrow, doesn't it? Yeah, those vectors would have arrows on them. Okay, the speed is the magnitude of the velocity vector. Would that make sense? If you have the velocity of the x component and the velocity of the y component, wouldn't the actual objects of a lot of speed be the length of the vector? And it's speed and not velocity because it's not signed. When you do a Pythagorean theorem, unless you put a plus or minus, you're going to get a positive value. So because of that, it's speed, not velocity. The acceleration vector is the second derivative of each piece. Moving down a little bit. The displacement vector, in other words, isn't displacement talking position? So it's the integral of the velocity. I don't know if you even need to write that down. I hope you're going, well, duh, right? If you want position and you have velocity, that's how you get there, is by doing an integral. They do call it displacement instead of position because it does not take into account initial starting value, of course, if you just do an integral. It does say the integral from time 1 to time 2, so that would give you displacement. What number is everyone on? 5's the lowest one I heard. Is anyone below 5? That helped, Ashton. You're welcome. And the last one is the total distance traveled. What does the total distance traveled formula look very much like? By the way, those are V's, which would be the derivatives, right? Arc length of a parametric. Doesn't it look like arc length? Wouldn't arc length and distance traveled be the same thing? Makes sense. So do you see how some of these equations are exactly the ones you've already memorized? Some of them are slightly different, but this is all the formulas you need to know for vector-defined functions in calculus. On which one? Yes. Yes. On number 6. You are talking about number 6. So in other words, you integrate velocity to get displacement, which makes perfect sense. Did y'all notice in the textbook that we are on the second to last section in the textbook? We skipped a chapter, but how many math textbooks have you gone all the way through in your math careers? Do what? Yeah, we just skipped one chapter we have to go back to. Sequences and series. No, we did skip it. I just wanted to do it right before the AP exam. The sequences and series. It's kind of the toughie. And we'll be done. It is in college. It's real hard in college. I think a lot of that is pace, and I think slowing that pace down, which we have time to do, I think it'll be much better. We'll see. It'll be the first time I've taught it, so, but it is the thing that in college people go. But remember, they have to do everything we did, starting from integration by parts in one semester. It's pretty intense.
you think should go back and actually start counting?
I would ask me again when we finish and talk about what you're going to major in and all those wonderful things. Like if you're majoring in chemistry and you have to take Cal 1 and 2, you take the credit and run and never look back. And yeah, so you might want to go back. Well, I would say, I would look at my AP score. I mean, if you make a 5 on the AP exam, you probably know what you're doing. You may not need to go back. If you make a 4 or 3, you may want to, look into going back. I mean, if you're pulling a 5 on the AP exam, you got it. We've got this stuff. Okay, example number 2. You already did example number 1 on the bell ringer. Example number 2. A lot of these problems are going to, in fact, when I was going through, before I had taught this, I went through and made your test before I made any notes or anything, and I went through and made your AP packet before I did any notes or anything to see what was on the AP exam. And there were times it was very hard for me to even pick out if a problem was a vector problem or a parametric problem, because they look so similar on paper. Until you hear a word like find the magnitude of the velocity vector, before that sentence, this could be a parametric problem, couldn't it? It's got an x-defined function, a y-defined function. So they do feel very, very similar. That's why we teach them back to back. So you will notice that this section feels a lot like last section. Okay. So says the position of the particle is given by x of t and y of t. Find the magnitude of the velocity vector, and what could they have said instead of magnitude of velocity vector? What's another word for that? Speed, right? So the speed, the magnitude of the velocity vector would be the speed, which makes sense because we're going to do the square root of x prime of t plus the square root of y prime of t. Isn't that what we're going to do? What was speed defined to be in parametric equations? So pretty much the same thing. So speed is the same formula in both parametric and in velocity, and in vectors. Okay, so step 1, I'm going to find the velocity vector. You probably could do this without actually writing down the velocity vector. That's a little arrow on top, and it's just indicating that this is a vector. You don't have to write it. So that is the velocity vector. Now, of course, I could come up with a generic speed equation or magnitude of the velocity vector equation, but I do want the magnitude at t equals 1. Would it be easier to plug that in now or later? Now, right? So I'm going to go ahead and say the velocity vector at 1 is 5, -3. And so the magnitude, and if we want to use vector notation, that would be the length of the velocity vector, is the square root of 5 squared plus -3 squared. And that is not 4. Don't do that. It happens a lot. Why is it not a 3, 4, 5 triangle? Quick mental note, because some of you will try to pull that. The 5's in the wrong spot, isn't it? It's on one of the legs. So 25 plus 9 is 34. Square root of 34. So that is the magnitude of the velocity vector. Again, that is the speed. So if I wanted to know the speed of the particle at time 1, that is the speed of the particle. Quick mental note. If the velocity at time 1 in the x component is 5, which way does that mean the particle's moving horizontally at time 1? To the right. Why to the right? Because the velocity of the x coordinate is positive. What about the y? What's it doing? It's going down at time 1. So some mental notes about what that velocity vector even means to us. Graph what? The velocity vector? No. I don't think so. No, just mental notes. Information. Who knows what AP will ask, right? They don't ask us to graph a lot of things, but they ask lots of questions. Particle moves along the xy plane, so the x is radical 3 minus 4 cosine t. Y is 1 minus 2 sine of t, where t is between 0 and 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the two x-intercepts. Do not evaluate. First of all, I want to know what formula am I going to need to use? The distance traveled, which is, what's the formula for that? From time 1 to time 2, right? Of the square root of x prime squared. Now, I think it actually said v of t, didn't say v of t squared, but Joseph is absolutely right. That's the exact same as x prime of t squared plus y prime of t squared dt. I could do a good portion of this problem just formula driven, right? What's the one thing they threw in that made this slightly difficult? I have to find out at what time I cross the x-axis, right? Because I need T1 and T2. Any ideas? Perfect. Does everyone agree with that? Y equals 0 on the x-intercepts? Any questions about why that is? So I'm going to do side note 0 equals 1 minus 2 sine of t. 2 sine of t equals 1. So sine of t is a half. That's a unit circle question. If you've forgotten everything you knew about the unit circle, what do? Draw a picture. Because I added that over. Draw a quick picture. Sine is positive in the first and second quadrants. Opposite over hypotenuse. This is a 1, 2, radical 3 triangle. So it's a 30 degree. Does everyone agree? So pi over 6 and 5 pi over 6. Any questions about how I know that? So I'm going to take the integral. X prime, what happens to the radical 3 when I take the derivative? Goes away. the derivative of cosine is negative sine, so I get 4 sine of t squared plus 2 minus negative 2 cosine of t. Is that right? It says set up but don't evaluate. Done. This one would not be one you'd be asked to evaluate without a calculator. However, if I change that 2 right there to a 4, that makes this very doable without a calculator because of sine squared plus cosine squared being 1. So they could have made this a non-calculator problem. They didn't, but they could have. Okay. Let's try this one. Okay, so on Tuesday, vector worksheet 1 and 2 are due, and the multiple choice AP vector problems, those are due on Tuesday. On Wednesday, you'll actually get a vector worksheet 3. That'll be due on Wednesday, and on Wednesday, we'll have a quiz over vectors. Any questions? I don't think vector worksheet 2 or 3 is necessarily harder than 1. I just had some problems in the 3 worksheets. So you can work them in any order you want. Both vectors 1 and 2 are due on Tuesday, and vector worksheet 3 will be due on Wednesday. Quiz on Wednesday. And then we will do polar coordinates, and that will be our last section in this chapter. 3 topics in this chapter: vectors, parametric. Yes, everyone listen really quick. Derivatives cannot be taken in degrees. So if you are doing calculus with a trig function, you are using radians because the basis for that derivative is in radians. So that's why we always stay in radians in calculus, because we cannot take derivatives. If you go back to the limit definition of derivative, you used a in radians to make the derivative of itself. Slightly different. Okay. So, part A, find the acceleration vector at time 2. We already have velocity, do we agree? So what is the acceleration vector at any time? We'll start there. Okay, before I go on, are there any questions about that one? So that is the acceleration at any time, but I wanted the acceleration at time 2. So I put 2 in, 12 cosine of 8. Everyone agree with that? Questions? Either way, it is a calculator question. You are allowed to put it in decimal. On AP, would they take 12 cosine of 8 instead of the decimal? Yes, if it's open response, if it's multiple choice. Look at the answers and you'll figure it out. Negative 4 sine of 4. So either that or the decimal equivalent would be awesome. Right? the equation of the tangent line to the curve at the point where t is 2. What do we need for tangent lines? X, y, and m, right? How do I find the slope? Good. I need to find dy dx. Well, what do you think dy dx is if I have an x component and a y component? And you said it already. The dy dt divided by dx dt, which is cosine of t squared over sine of t cubed. Don't be tempted to change that into a tangent. Why would I not want to do anything crazy like that? Good, it's not the same. So I do want to evaluate that at t equals 2. So I get cosine of 4 over sine of 8. And again, you can find the decimal equivalent of that. Make sure you do 3 decimal places, or you can leave it there. It is very kind for part B. I know the position at time 2. I know my x coordinate and y coordinate. Does everyone see that? If it didn't tell me that, this would become a much more complex problem, wouldn't it? Did y'all not see it?
Yeah, I was trying. I realized it gives us.
Yes. We'll talk about what would happen if they didn't give us that information in a moment. They would have had to give us something, but speed of the vector. What is the speed of the vector? And how are you getting it? Oh, were you answering? I thought you were answering. Were you answering the question? No. I thought I heard you saying numbers. How do you get the speed? Derivative at 2 squared plus the of x at 2 squared and the derivative at 2 of y squared. So wouldn't that be cosine of 4 squared and sine of 8 squared? How did I get those so fast? Where did those come from? Yeah, in part B, I had already found those derivatives at 2. So I am cheating a little. It would be okay if you hadn't done that, and then you could do the work.
Is the magnitude and speed the same?
The magnitude of the velocity vector is the speed of the particle. Because, let's talk about that really quick. I'm going to go back to a blank page for a second. Quick side note, total random. Okay, if I have a vector, and I know the x component is going at 50 miles per hour, and I know the y component is going at 30 miles per hour, then how could I find the vector's speed? Pythagorean theorem, right? So when I have the velocity vector, I have the velocity in the x direction and the velocity in the y direction. So I use the Pythagorean theorem to get the velocity in both directions, right, of the actual particle. Does that make sense? So the x component velocity is how fast it's moving in the x direction. The y velocity is how fast it's moving in the y direction. But the actual particle, to get the speed of that, I would need to do the Pythagorean theorem. I don't know why now I've decided I want one, but will someone actually give me that value?
Which one?
The 1.18. I don't know what my units are, but if there were units on the problem, I would put them down. It would look something like miles per hour or feet per second or something.
Doesn't it say not calculator at the top?
No, it says calculator.
Oh, just
yeah. So you can.
just
But you could leave it. I mean, you know, AP is pretty flexible.
had some keys turned into the office. They work down in the girls' locker room in the PE gym, and they are for a BMW. Thank you.
Position of the particle at time 1. How in the world do I do that? Why am I going to integrate? Because I have x prime of t and I have y prime of t. If I want x and y, I need to integrate. Now, I have to use some information though, because what do I get if I integrate? Okay, I got a plus c, or I get a displacement. Do you agree I get a displacement if I integrate? So, how do you get position? What do you have to use to get position? You have to use an initial condition, which we are given the 0.14. We will do this tomorrow because the bell's going to ring. So we'll finish this one tomorrow. I have one more example after this. So we've got 2 slides tomorrow, and then you'll have some time to work. This slide will take us a while.